next 200 years of research was proving that these galaxies, this is a billion stars in a little dish called the sombrero, that these objects were not inside our Milky Way, but were extended out into the universe. This idea drove much of the work that I'm going to show you. Herschel was the great astronomer of the 18th century, and his goal was to show that Kant was right. This is a picture of a little 7-foot telescope, probably about 10 inches in diameter. By this time, they knew how to figure mirrors somewhat. They couldn't build really fast telescopes, but they could build telescopes. If you're a camera person, this would be about f10. And this was certainly the best telescope of the day. You notice it's on wheels. So you just have this rigid thing. You point at a star. Here's a little guide telescope. And if you want to change stars, you rotate the whole structure on wheels. Obviously, you don't want anybody around. They might kick it, so forth and so on. Very delicate operation. He went up to a 20-foot telescope, which is about 18 inches in diameter. Here you see the wheels again, and you notice it points up and down, and then you rotate it on the wheels to point sideways. If you're an amateur, you know this is called alt-azimuth mounting. And so he could look anywhere in the sky. He stood up on all these structures here. The eyepiece was up here. It's called Newtonian telescope. He's an amateur. He was a musician who got lucky and found a planet, named it after the king, and the king gave him a stipend. Very good strategy. And so he was able to pursue his work. He polished all his own mirrors. The mirrors are made of metal, not glass. He cast the mirrors. He built the structure. He had a lot of people working with him, and he could afford that. This was his favorite telescope, and with it, he cataloged some 9,000 or 10,000 galaxies. But of course, you always want to go bigger. This is the medal of the Royal Astronomical Society in England, which has a sketch of a similar structure. This, in this case, is a 48-inch telescope. You could actually stand inside of this. Haydn did stand inside of this and saw the sky all around him, how wonderful are the works of God, et cetera, et cetera. So these scholars and intellectuals all knew each other, and since Herschel was a musician, he invited Haydn to come out, and it was a very good experience. This was finished in 1789, and this telescope was finished in July 1776. So now, like the Sistine Chapel, you have another benchmark. This is the month of the signing of the Declaration of Independence in America. Britain was at war, but it didn't bother the scientist. He just went ahead and did his work. Herschel made many great discoveries. Many people think that he's the greatest astronomer of all time. In particular, he discovered that most stars are binaries. The question he was asking is, can I measure a parallax by looking at these close stars, one faint and one bright? He thought one was far away, one was close by, and that the one that was far away wouldn't move, because the one that was faint wouldn't move because it was far away, and the one that was bright in front would have a parallax, okay? That didn't happen, but he discovered the stars are going around each other, and that is the basis for all of stellar evolution, which I will show you in just a minute. His sister Catherine discovered, I see different numbers, I think it's 9 comets. She's by far the most prolific comet hunter in history. And she would sit at the bottom of those big telescopes taking notes as he hollered out what he saw. They were a team for their whole lives. She unfortunately died in poverty in Germany, unrecognized, but now she's being reinstated. He made a map of the universe, which I'll show you in just a minute. Had the first actual theory for how the Milky Way got its shape, how the stars gathered. Discovered infrared light. This was the first light not detectable directly by the human eye, and that presaged radio astronomy, X-ray astronomy, so forth. Built the catalogs of nebulae that we still use today. But he couldn't prove Kant's idea about the galaxies. So this was left for somebody else, and it continued to drive astronomical research. This was his map of the galaxy. You notice this little cutout here. This is what the real galaxy looks like. And you can see this dust lane across the center. he was simply not able to see all these stars over here, and he couldn't see the stars in here because they were covered by dust, which you can see in his picture. So he didn't know how to interpret it, but at least he made the map. Now I just want to say a word about eyepieces. There was the optics, and I talked about the trouble of making a lens or polishing a mirror. The other end of the telescope was very difficult because Newton said that we only can work with reflecting telescopes. In principle, you can't have a piece of glass, a clear piece of glass, that will focus anything but one color. And I just can't imagine the horror of the people who ignored this and just went ahead playing around when the great Newton said it wasn't possible, but that's actually what happened, and of course Newton was wrong. So I don't have time to go through this, but this does have the beginning of a theme that I want you to get out of this. Two themes, actually. First of all, the credit for making an eyepiece that was made of transmitting lenses and that would focus all colors of light eventually went to a man named Dolan, who won a 10-year court case. The reason he wanted to win was that he could sell the optics to the army. There was a lot of war going on, and he made a huge amount of money, and his family made the best optics for 100 years after that. These were almost state secrets. I mean, they were private secrets, never revealed. You just told them to people in your family. Okay? He actually stole the idea, and it's a long story, but that's part of the kind of humor of astronomical successes. And the last thing about the eyepiece is that Herschel learned to make really, really highly magnifying eyepieces, and that was the reason for his success. He could resolve double stars, see them moving around each other. He made eyepieces with magnifications upwards of 3,000, and to this day, nobody knows quite how he did it. So these private mysteries are kind of a fun part of the history of the telescope. Now, I found this sad story of Herschel about how tough it was to observe with the thing up on top of wheels. The bigger it is, the bigger the wind's going to be. Who knows how many people had to stand on the platform to hold it still. And he had to be shouting out orders. And he just lists all the things that go on in this really bad part of England where he built the telescope. The metal mirrors had their temperature changed through the night. You couldn't keep them constant. And the image, as the mirror would flex with thermal changes, the focus would change, so you had to keep refocusing. It was really, really quite nasty. The air was humid, and the mirror would frost over. It was a metal mirror. On frosty nights, it would get so frosted you had to let it thaw, so you had to let the sun come up and thaw it before you go back to work. Very, very frustrating. The mirror would flex because it wasn't properly supported from the backside. It's rigid, but it still bends. These are metal mirrors. They tarnish in the air, so you have to constantly repolish them. It's said that he either observed or polished optics. That's all he did his whole life. So if it was a cloudy night, he just went and polished. And then, of course, clouds. I'm not sure this is right, but talking to some friends of mine who know this part of the country, we're guessing that he had 10 completely cloudless nights a year, okay, which makes it very hard to make progress. So he couldn't do his best work except under very, very rare conditions. Lost many hours due to mist and frost. Could observe best when he was looking straight up, because if you tilted the mirrors, then it flexed and curved and so forth. Had to maintain an optical shop on the side, cost a lot of money. And for all those reasons, he used his 20-inch more than he used his big 48-inch telescope. After, during Herschel's time and after his time, all the different subsystems, the support structures, the quality of the optics, all these things improved dramatically. And by the 19th century, people actually had learned how to make doublets that would focus all colors of light, and people went back to making refractors. The two great men of that time were Fraunhofer, who many of you have heard of, who took the first spectrum of the sun, made gratings. He made the best glass in the world, and his company also profited from 100 years of making telescopes from the military. One of his employees, who left in a disgruntled matter and